Hi students, in this lecture I am going to discuss problems based on spherical mirrors. Let us see first one. See the question. A concave mirror of focal length 20 centimeter is cut into two parts from the middle, and the two parts are moved perpendicularly by a distance 1 centimeter from the previous principal axis AB. This is now the original principal axis. The distance between the images formed by the two parts, if the object is kept at a distance of 10 centimeter from the pole of the original principal axis, is, so given distance of object 10 and focal length is 20, we are moving by a distance 1 centimeter perpendicular to the principal axis. So we have to find distance between the images, right? See how to start. So first note down the given data. This is now concave mirror. Given focal length 20 centimeter, distance of object that is given as 10, right? So light rays are now traveling towards right side. That means right of the pole is positive x-axis. This is now pole. Light rays, the instant light rays are towards right side. So right of the pole positive x, left of the pole negative x. That means object coordinate will be minus 10 centimeter, right? That is u. That's why distance how much? 10. And given focal length. Focal length means distance of focus from the pole. So now somewhere here focus, right? It's a coordinate. It is minus 20 centimeter, right? So we got coordinates of object and focus. Let us first focus where image forms. Okay. Use now mirror equation. 1 by f equal to 1 by v plus 1 by u. F value minus 20. Right? This is a coordinate of the focus. Next, coordinate of object, that is minus 10. Now substitute these values in this one. Minus 1 by 20, that is equal to 1 by v plus 1 by minus 10. Right? That means what we get here. 1 by v equal to 1 by 10 minus 1 by 20. Right? Then see what we get here. 1 by 10 minus 1 by 20. From this v value, 10 into 20 by 20 minus 10. That is a 10. Right, cross check once. 1 by f equal to 1 by v plus 1 by u. And sign convention. F minus, it is minus 20. U value minus 10. I am taking this one to left side. So it is now 1 by 10 minus 1 by 20. So from that v value, 10 into 20, by 20 minus 10. This is now 20. And remember, we got this value post. Its meaning is that image is now virtual. Image is virtual. Okay. Next. And see one more point here. Magnification. That is minus V by U. U negative, V positive. V negative means, so I'm substituting values here. V value 20. U value minus 10. This is now how much? 2. Magnification we got plus 2. It means image is virtual because we got V value positive. Next, M is plus 2. It is plus means erect 1. It is now 2 greater than 1 magnified. Virtual erect magnified. So this image forms behind the mirror. Virtual means it forms behind the mirror. Now coming to our problem. This mirror is cut into two parts. Okay. See diagram for that. This is original principal axis. This is one part. And this is now second part of the mirror. Now you can see for those to the principal axis. So here key point is that when we cut along the principal axis and after cutting, we are displacing this perpendicular to principal axis. That means now for this one, this is the principal axis. For the upper one, this is principal axis. And for lower one, this is principal axis. This is a principal axis. Okay. Yes. And see where is object. This is now object. Right. Now you can see we got magnification plus 2. So image will be behind the mirror. Okay. Erect one. Now focus carefully here what we are doing. This is a point object. If we focus, if we are focusing the upper part, for upper part, the object is now below the principal axis. For upper part, object is below the principal axis. It is just like object of height equal to 1 centimeter. I am taking this as a. So AO is object of a height 1 centimeter. It is below the axis, right? And you can see magnification, we got plus 2, erect 1 and magnified. Then see what happens. For this one, I am taking it as A1. Since it is now 1 centimeter, image will be having a height of 2 centimeter because magnification is 2, which is height of image by height of object. That means height of image will be 2 times height of object. Okay. That means image will be now like this. This is now image of O. I am taking this as O1. Image by upper one because this is 1, this is 1. Okay. That is image by the upper one. Now in the same way, coming to by lower one. For lower one, this is an object above the principal axis. I am repeating. For lower one, this object is now above the principal axis. Object of height. See carefully. It is object of height 1 centimeter. This is 1 centimeter. That is called as B. Object is now BO. Height is 1 centimeter. Magnification is 2 and plus 2, erect 1. That means image must be actually at same location. Okay, na? It is at same location. Means image of B will be, I'm taking it as B1. Image of B at same point. Image of O will be at the location of A1. Get the point. Image of O will be at the location of A1 because height is now 2 centimeter, right? That means by upper one, image of O is now O1. By lower one, image of O, it is take it as O2. Is the point clear? So see carefully. For upper one, it is now below the axis. Image in the same way. I will draw here separately to get more clarity. So image by the upper one, it is like this. This is I'm taking as O1, image of O by the upper one. Okay. So this is object. This is A and this is O. Image of O is here. Size 2 times. Okay. At same location, we get image of O because of lower one. That is, this is image of that I'm taking as O2 because it is now like this above the principal axis. That means between these 2 points, separation is now 1 plus 1, it is 2. Okay. That means between those two images, separation is equal to 2 centimeter. Okay. So key point is that when we displace like this, principal axis also will be displaced. It is also displaced. So this is the principal axis for upper one. This is the principal axis for lower one. Okay. So, see the next problem. So this question is taken from H.C. Verma. See the question. Find the diameter of the image of the moon formed by a spherical concave mirror of focal length 7.6 meter. The diameter of the moon is 3450 kilometer and the distance between the earth and the moon is 3.8 10 power 5 kilometer. Okay. So we have to find diameter of image of the moon. Right. Now see how to solve the problem. So first note down the given data. Diameter of the moon. I can say diameter of object because moon is now object. That is given as 3450 kilometer. Now distance between moon and earth. Distance between moon and earth. I'm taking it as yes, distance. That is given as 3.8 10 power 5 kilometer. Next, focal length is given as 7.6, sorry, 7.6 meter, right? It is given 7.6 meter. Now see how to solve it. Let us make a diagram. Right. So it is given concave mirror, concave mirror. So here the main point is distance between Earth and Moon. It is large. When distance of object is large from the mirror, rays are parallel. But these rays are not parallel to principal axis. Okay. So I'm taking here a parallel beam. Or let us take now. This is moon. Okay. Rays coming from the moon. In fact, they are parallel because separation is very large. Now they reflect. So distance is very large. So instead we are taking light ray at the pole. After reflection, we can see when rays are parallel. I will draw a diagram once again here. When rays are parallel but not parallel to principal axis, means like this. Okay. The rays are parallel but not parallel to principal axis. They converge or they form image. They form image in the focal plane. Right? We have discussed what is a focal plane in the beginning of the chapter, right? Now we can see this is now focal plane. So this is now diameter of the image. Okay. This is a P. This is now F focus. Okay. Now this is angle of incidence I. Angle of reflection also same, right? Both are equal. P. This is F. Now see what we can do it. P F. Take it as this is A. And this is B. And this is a C. Now we can see triangles. Triangle A B P. Next, it is F C P. From these two triangles, see what we can write. Tan I, tan equal to opposite by. This is nothing but diameter of image. Diameter of image upon. Okay. This is now focal length, right? Focal length is now 7.6 meter. That is equal to. Now in this triangle ABP, tan I equal to diameter of object, that is 3450 kilometer upon EAP. EAP means distance of moon from earth, that is 3.8 10 power 5 kilometer. Right? Now see what is the answer. From this, diameter of image is equal to 7.6 into 7.6, 3.8. 3.8 here, how many times? 2 times, right? 2 times means it is now how much? 3450. So 1 0. This is now 10 power 4. Remain 345. That becomes now 690. 690 10 power minus 4 meter. Sorry, it is a kilometer, right? Kilometer. That means its value is now 0.123. It is now 0.069 meter, right? Because a kilo means 10 power 3. Okay. Let me cross check units. What I have taken right or wrong. This is 690. 690 10 power minus 4 kilo 10 power 3 and this one and 0 and this two gets cancelled. This is now meter, right? Okay, 69. Sorry, this is how much we got here. 7.6 meter. This is a meter. This is now kilometer. This is also kilometer. So we got answer is now in kilo. Both are gets cancelled, right? Kilo. There is no kilo here. Let me correct it once. This is not kilo, just meters. See calculation part carefully. This is kilometers. This is also kilometers. Both are gets cancelled. This is now given in meters. Therefore, finally, this is in meters. Therefore, calculation here covers right. So it is now directly 1, 2, 3, 4 means 0.069 meter. Okay, because we have to focus the units given carefully. So here key point is that distance of the moon from the mirror is large. That's why rays are parallel but not parallel to principal axis. In such a case, image is formed in the focal plane. Focal plane means it is a plane which is normal to principal axis and passing through focus. That is what we have discussed in the beginning, right? And remain just using the geometry. Okay. Let us see next problem. This is a previous IT question asked in 2007 for 3 marks. See what is given. In an experiment to determine the focal length of a concave mirror by the UV method, a student places the object pin A on the principal axis at a distance x from the pole P. The student looks at the pin and its inverted image from a distance keeping his eye in line with PA. That means, so he is looking at the image by keeping his eyes along the principal axis, right? The meaning of in line with PA. So P is pole, A is now object pin on the principal axis. That means person is keeping his eyes along the principal axis and watching the image. Image is given inverted. When the student shifts his eye towards left, the image appears to the right of the object pin. Condition is, so here key points, it is inverted. Okay. Next, when the student shifts his eye towards left, the image appears to the right of the object pin. Then, so we have to focus where is the object, right? Is it like between pole and focus? So I think one thing we can say, option A is not correct. The reason is when object is in between pole and focus. See carefully, x is less than f. That means where is object? It is between pole and focus. Then image will be virtual, erect and magnified. It is given inverted. So this is not correct, right? Next. Next, we have to focus remaining 3 options. Okay. I think even we can verify directly option C because x equal to f means image and object both will be at same location, right? So the remaining 2 options are B and D. So now these two we have to verify. Let us see. So condition is that when student shifts his eye towards left, image is right of the pin. Right. This is now mirror. This is a cone, and object is now somewhere here. Object is C. Now condition. See, we are having now focus somewhere here. It is clear that object is not in between pole and focus because image will be for this region virtual, erect, and magnified. So object must be now in between, maybe between F and 2F or beyond 2F. Okay. That is what we have to verify now. Right. Right. Now we are having somewhere here C, center of curvature. It is center of curvature. So now we have to focus that where is image. Okay. Now recollect once. Recollect once. When we have object in between F and center of curvature, object in between, image will be beyond center of curvature. I am repeating, if object is in between focus and center of curvature, image will be beyond C. That means left of C. Okay. If object is left of C, image will be right of C. Okay. Let us now cross check. Object is now between F and center of curvature. Okay. Between F and center of curvature. Somewhere here. Then image will be here, right? If this is object, image will be left of C. Sorry. Yeah. Left of C. Now see what person is doing. So object is now A. This is A. And this is B. Now he shifts his eyes towards his left side. Now what I am doing here is assume that person is now seeing a long PA. That is what given, right? So I am taking a person is now standing here, right? And I'm saying that his left hand is above this axis, right hand is below this axis. Okay. Or if you see from the top, left hand in this region, in this way, right hand is in this way. Now person shifts towards, now person shifts towards left. When person shifts towards left, see where is image. Okay. When person shifts towards left, where is image? It is given towards his right side, right? This is object. When he observes, means shifting towards left, you can see image will be right of this line. Get the point. Now person sees here, image will be right of this line. Get the point. Which is matching with the given condition. I am repeating. When person sees from towards his left side, I am just imagining one line passing through object. Now this is a line of sight and image is now somewhere here. And where is image means right of this line or right of the person. Is a point clear? And I will take next example. It is if object is beyond center of curvature, then image will be between F and center of curvature. Okay, means somewhere here image. Now see what happens. This you have to understand very carefully. Now the person turns towards his left side. Now person sees in this line. He sees in this line. Now image is to his left side. We can see image is now to his left side, not right side. But if object is now between F and center of curvature, when person sees in this line, image is now right of this line. Get the point? Means this is now matching. That means object must be in between F and center of curvature. Okay. If you are given condition like it is it is left side, then object must be beyond center of curvature. So for this given question, correct one is now it is in between F and center of curvature. Okay. This is image which is inverted, real and magnified. Okay. So see the option. It is option B, right?